let's continue with 17C. So what we're going to look at is how to approximate the distribution of a sampling proportion. What we've seen in 17B is we worked at the exact distribution of the sample proportion, and it will, depending on the population size, we looked at if for small population we do calculations using selections, and for a large population we approximate to a binomial distribution. That was only doable if the sample size was small. Now for larger samples, we will approximate the distribution of the sample proportion. So what we're going to do is use the CAS calculator to generate that data, and we're going to use some tools to tally that data in a table, to generate a scatter plot, and from that you can also do simple statistic calculation like the expected value and the standard deviation. So let's start with the population data. So we know the p-value, it's a binomial, it's 55% for Australians to have blue eyes. Let's look at the sample size of 100. So what might be the value of the sample proportion p hat? If we do a first sample and we get 45, you do 45 over the sample size, that gives you 0.5. That's your first p hat. Now we're going to use the CAS calculator to generate a number of samples. So first is you create a spreadsheet. Now we do that in a spreadsheet, but the function is available in calculation as well. So once you have your, let me get a laser. Once we get your spreadsheet, you press menu and you go to data random binomial. So it's a function. And then we're going to enter a series of parameters. So the last one, divide by 100, it's your sample size. So we're going to get a proportion, which is your p hat, and that function will generate value according to that. So here what you need to specify is 100 is your sample size, which is what you have at the end as well. Your population proportion, or your p-value, and 10 is the important one, is the number of times you want to repeat that. So 10, and it will fill down as you do. You enter that in that cell. That has to be in that cell. That cell under the name is related to when you apply a function, it will apply it to the column. Also, another thing is good practice, always rename your variable to something meaningful. As you move to the scatter plot, if it's not renamed, it will use the A description as a default. So in that next screen, you get the p hat generated 10 times. Now, how to display that data is you're going to use it's the data and statistics graph page. You will need to, in the options, you'll choose your variables, then you will need to change it to the type of display you want to do. So here we're going to change it to a histogram, and then we're going to display the PDF, which is menu analyze. It's the line approximation of what the histogram looks like. So you have your raw data. You're gonna move to the bottom to select your variable. Then under menu plot type, you're gonna choose histogram, because at the moment it's just a dot plot. So histogram to get the bar graph basically. bar graph histogram, yeah. And then we're gonna overlap the PDF. So you do analyze, show the normal probability density function. So it's a normal. That's what I was after. So it's a normal PDF approximation from the data, and that's what it looks like. Okay, and it will specify some the normal PDF features. All right. Now let's repeat that with a larger number. So we're gonna repeat those. If you want to do that, good idea to do that on your CAS. You can pause the video to look at those menus, or you can use your textbook. It has a few examples how to manipulate that with the CAS, either the Texas Instrument or the Casio. Again, data random binomial. Here we're gonna have the sample size again. So 100 we divide by 100 because it's a proportion. Your probability of your variable and the sample size here. We enter that in that cell. What you do is go back to that page, override the previous function and adjust accordingly by changing the sample size here. You can see you have 200 rows, 200 values. Then you can go across. You don't need to generate a new scatter plot page. Can't remember what it's called. The data, sorry, data statistics page. So here again, for your reference, you have all the menu. But if the data is already generated from the previous example, if you move over, the information will be updated. So here, let's say you start from scratch. You go to the home page, you add a data and statistic graph page, you pick your variable. At the moment it's a dot plot, so you're going to change it to menu plot type histogram, like that. And you can see now it's starting to look like a bell-shaped curve, which is approximating a normal distribution. Let's do that by overlay a normal PDF, analyze, show normal PDF, and here it is displayed overlay over the histogram. Alright, now from that you can get some statistic calculation, the mean and the standard deviation. So use the same document that you had before. As you go back to your spreadsheet, you press menu, statistics, stat test. It's a one variable. You're going to select the data from the first column, and here it is. It will provide all the data for that first column. So you will have your mean here and your SX, which is for your sample. You get your standard deviation down here. So you get all your measure of a center and spread all in one place. So here it is. Now hold on, just give me a sec. So what we have here, so this is a larger sample, so we had 200, and you have the mean and the standard deviation. So it's a sort of conclusion, but as you're experimenting with a larger sample, the number of sample, and also with the sample size, the sample proportion p hat has an approximately normal distribution, and with a normal distribution there's two features that you require. Is the mean that will approach the population mean, and the standard deviation will follow that formula, okay, based on the population proportion as well as the sample size. So we've done that again with this, And that's it for 17C, and I see you for the last video on 17D. See you later.